Hi, welcome to the channel. Hope you're doing great. So today we will learn about feature engineering or text representation. In the previous couple of lectures, we learned about what is NLP and what is the standard pipeline for NLP, how we can train our model and all that. And we also learned about text cleaning or data cleaning. We learned about text pre-processing. We discussed various techniques for text pre-processing and also for text for data cleaning. So we learned about all those things in the previous couple of lectures. If you haven't watched those videos, I would put the link in the description. Please first check that out and then continue with this video. And if you're new here, I would request you to subscribe to the channel because that helps a lot. So with that being said, let's continue with the with this lecture. So here we will, as I said before, we'll discuss feature engineering or text representation, which is basically converting your text into vector or numerical form, because our computers only understand our computers are our machine learning algorithms only understand numerical representation. So we need to convert our text into number format. Okay, for that we use different techniques. We have different classical approaches, we have deep learning approaches. So in this lecture we will mostly focus on classical approaches. In the next coming lectures we'll discuss deep learning approaches as well. So in classical approaches we have one-hot encoding, then we have bag of words, then we have bag of n-grams or term frequency or inverse document frequency, which are classical approaches to feature engineering or text representation. We'll discuss these one by one, and also will implement this in Python. In the next lectures, we will discuss deep learning approaches like continuous bag of words or skip-gram. We will also learn word-to-vec approach developed by Google. Then we will also study Globe, which is by Stanford, and then we'll also learn about fast text, which is by Facebook. Okay, so we'll learn about all these approaches of feature engineering or text representation in detail. So let's learn about one-hot encoding. What is actually one-hot encoding? As we discussed before, one-hot encoding is yet another method for representing texts into numerical format. Our machine learning algorithms don't understand categorical data or text format of data, so we need to transform those or represent those data or texts into some kind of numerical format so that they could be used or consumed by our algorithms. Okay, and if we formally define one-hot encoding, it's a method for converting categorical variables into binary format. It creates new column for each category, where 1 means the category is present and 0 means it is not. So the primary purpose of this is to ensure that categorical data can be effectively used in machine learning models, as I said before. So let's say after cleaning and pre-processing techniques we got data like this. We got this data where the data which we had is being transformed into different documents. These are what we call as documents. If you're not familiar with corpus, vocabulary, document, word, token, these sort of things, I would suggest you to first check those words or nomenclature first in order to understand this thing in depth. Okay, so after applying all the pre-processing steps, which I'm sure you have an idea about if you're watching this video, if you haven't watched those, I would again suggest you to first watch those videos and then continue with this one. So after applying the pre-processing techniques, we got document 1, document 2, document 3. These are 3 documents we have out of our processed data or text. Okay, so if we talk about the number of vocabularies or unique words in this documents, we have 4 words. I'm simplifying it so that you could get the idea. In real world, you wouldn't have just 4 or 5 or 6 words. You would have thousands of words. Maybe it could be 50k, 60k times words. Okay, so I'm just trying to simplify it here. We have got student, we have got learn, we have got NLP, and we have got tech seeker. Okay, so these are 4 words. Now we need to represent these words in some sort of numerical format or vector format. If the word is present, to represent any word, we would just use one, as we said here before. Or to represent the category, we use one, and the absence would be represented by 0. So that's what we are doing here. For student, we would use this vector. For NLP, we would use for learn, we would use this vector. For you know NLP, we would use this vector, and for Texico, we would use this vector. So that's how we can represent any text into vector or numerical form using one-hot encoding. Okay, so there are some pros and cons of one-hot encoding, which I've pinned down here. Include it removes ordinal relationship. Let's say here you can see that student learn NLP is a sentence. They have a particular relationship with each other, right? But here you can see it represents them randomly uh, in a vector format. It is better for many algorithms, and it's simple and easy to implement. There are some cons as well, or flaws of this method, which includes high dimensionality, which is the dimension of the vector could go up to 50,000, 100k or more in real time data, and sparse representation, which is most of the metrics consist of zeros, leading to inefficient memory usage, as I said before. And it also not suitable for large data, because if you have large data, then you would see, if there is one bit presenting the word in a large data sets, then there would be hundreds of 100k of zeros representing nothing. So that's why it's not suitable for large data set. And yeah, so that are some of the cons of one-hot encoding. I think you got the idea what is one-hot encoding. There is nothing much to uh, study in depth about one-hot encoding. I think that's pretty much it. So let's move on to implementation. Alright, so here I have implemented one-hot encoding, where I first imported numpy as np and pandas pd. Then I have imported one-hot encoder from scikit-learn p-processing, and then I've opened the file. So let's run these one by one. Okay, and then I've opened the file, and then here I am just tokenizing the documents we have. We are using this cleaned data which we have here. This is a whole lot of document, okay, which has been cleaned after removing different store words and all those things from this. So here I am just splitting into different documents. So then I am converting each document to list of words from the vocabulary we have. I have just initialized object of one-hot encoder here. This is our one-hot encoder, and I'm fitting flat docs to the documents which we have here, which are just a list of words from the document, which we split it here just above here. Okay, here using one-hot encoder, we are transforming the encoded matrix or the encoded vector into matrix format. Okay, and then using pandas data frame, we are just printing it for better visualization. Okay, so if I run all these from here on, you could see one-hot encoding is percent. Okay, and here we go. Here you can see
we got the vector format of the document. So we have, it has 215 columns, which means that we have one unique variables here. Like if we had a small text, we could have better visualization. Like if I just go here in the clean text and just uh, cut it into, just make it, you know cut this out, visualization. Okay, so from here onward, and yeah, here we go. So here you got x content, n content, example, grammatical, it and it. Here you got c, that we have got the one hot encoded output here. So that's how one hot encoding work. I hope you got how the implementation work here. Now let's undo all these, save it. Okay, so that's all. Let's move forward and let's learn the other techniques.
Now next we have bag of words, which is again a method for text representation, and it's a simple way to convert text into numbers. It represents a text as a collection or bag of words without considering the order. Now, uh, as you can see in the one-hot encoding, the order of word was not being captured. Similarly, in bag of words, it also don't consider the order of grammar. Okay, and if you talk about the way or the approach in which it uses to represent the text into numbers, here you can see the steps. After applying the pre-processing steps, we got this, you know, this data as we had in one-hot encoding. Then we have 5 unique vocabulary, uh, same as the previous method. Now, in order to represent the text, we don't need a 4 by 4 matrix here. You can see I've written here 3 by 3 matrix. The reason is that in order to represent the document 1, D1, here in D1, I'm representing this D1 here, where if the student, if the keyword or the token is present in this document, I would write 1 uh, there, and if it's not present I would use 0 against that to represent anything. So that's how we could transform this whole document or this whole file into different vectors. Here you can see for D1 we have this vector, for D2 we have this vector, and for D3 we have this vector. So that's how we represent um, text using bag of words. I think you got the idea how could we use bag of words. I don't think there isn't anything difficult here. Now, why use bag of words? Bag of words is again is more efficient than one hot encoding because the number, as you can see, the number of zeros which we had, a kind of sparse representation, a large number of zeros which we had to use to represent different vector, different tokens. But now here you can see that's not the case anymore. So it's more efficient than one-hot encoding. Therefore, we could use it for text representation. Now it's used in various cases for various applications like sentiment analysis, for spam detection, for topic classification. Could also be used in search engines, plagiarism detection, and more. Now there are some pros and cons as well. It's simply to implement, like the one-hot encoding. I think you would agree with me on this. Then we work well for text classification and good for small data set again, same as the one-hot encoding. Now there are some disadvantages as well. It ignores word orders, like one-hot encoding. It also
ignore word order, like I love Python and Python loves me have the same representation, even though they have different meaning. And it also have a curse of dimensionality or high dimensions. So if there are many unique words, the matrix become very large, and it doesn't capture semantic understanding. That's again a very, of a disadvantage of this method. It treats good and great as completely different words, as you can see, even though they have similar meaning. So that's are some of the pros and cons of bake of words. I think you got the idea. Now let's move towards the implementation of bake of words.
Alright, so here let's implement a bag of words here. So first thing we need to install scikit-learn. Scikit-learn. So for that, pip install scikit-learn and let's run it. It's taking a little bit time. So requirements already satisfied because I had installed it earlier. Now let's move forward. The next thing is let's open the file. Open the file or read the cleaned data. Okay. So for that, with open, it's suggesting us. That's great. Let's save this. And here we have this clean data. Now the next thing is we need to import the vectorizer from scikit-learn. So we could use the vectorizer in order to convert this data accordingly. Okay, so for that, from it's already suggesting here from scikit-learn feature extraction.txt, and we are importing count vectorizer. So then let's initialize it. Instance it's already and the next thing is we need to convert or fit the vectorizer. Oh, it's all bag of words matrix bl2 clean data dot is split. I don't yeah, that's also okay. And the next thing is we would print the bag of words. Okay, not the shape but the features in the data. Okay, so for that we would just print that's it. And then next let's print the matrix into array. So let's run this and let's see how it goes. Alright, there is an error here. Okay, I think we don't need to use this split function. Here we could just use the clean data. Let's run this again. Okay, I haven't run this. I forgot to run this earlier. So it's showing again an error. I think we need to split the line here, which was important. Now let's rerun this, and now here you can see our data has been vectorized. These are the features which we have, or the words which we have, all these words in our text, unique words, and this is the vectored form of vectorized form of this data. Okay, so that's what we got here after representing our text in bag of words. That's the implementation of bag of words. Now let's move forward and let's learn the other way which we could represent this text.
Bag of words still have some flaws in it. It doesn't capture the semantic or meaning of the document or the data we have. So in order to solve that problem, or use bag of n-grams, which is a kind of upgraded version or an extension of bag of words approach. Um, it is designed to incorporate sequence of n-grams into text representation, and this method capture contextual information by considering contiguous sequence of n words. Now, how does that work, or what's the meaning of the definition which we just read here? Um, so let's understand that after applying different techniques, we got this idea as the previous steps. Okay, now here we have got different n-grams, yeah, bigrams. So the n-grams means you could take two words at a time. Here we have got two words, student learn. We could also take three words, four words, five words, whatever best suits your model. Okay, then you could use those n-grams in your representation. Okay, for example, here you can see. So we have student learn, then we have learn NLP, then we have NLP student, then we have student Taxico, then we have student learn, then we have learn Taxico. So these are the combination of two words which we are taking in order to capture the semantics of, or the meaning of the word or the data we have. So in order to represent this in a vector form, same as bag of words, we just need to check if a particular phrase is present in the document or not. For example, student learn is present in document 1, so we would represent that by 1. Learn NLP is present in document 1, so we would represent that by 1, and for the rest of them we would represent them by zeros. Same with the document 2 and document 3. So that's how we could represent a data in our text using bag of n-grams. Okay, now to understand a bag of n-grams, you could just read it out. I think you got the idea. It's not that difficult to understand. It's similar to, or it's same as, you know, bag of words. Just here, instead of using one word, we are taking just two words, three words, or n words at a time, and representing them through different vectors. Okay, so that's the basic concept behind bag of n-grams. Here you can see an n-gram is a contiguous sequence of an item. In NLP, these are typically words or characters. For example, in unigram, you could use single word. In bigram, sequence of two words. Trigram, sequence of three words. And for example, we have a quick brown fox. For in unigram, we would take quick brown fox uh, separately. In bigram, we would take the quick brown fox to one another, then trigram, the quick brown and quick brown fox. So that's how we represent, you know, the you present text in bag of n-grams. Okay, there are some pros and cons of bag of n-grams as well. It has contextual awareness because it takes two words and the context of those, so it certainly has a contextual awareness. Like it captures local word order, enhancing the understanding of phrases and expressions, and also improve the performance. So it often lead to better results because we are taking two words at a time, which improves performance. Uh, and then there are some flaws or disadvantages or cons as well. Again, dimensionality increase, which the feature space grows exponentially with the value of n, leading to higher computational costs and potential overfitting again. And also data sparsity, because here you can see that in order to represent one document we are using just two ones, rest everything is zero. So that's kind of data sparsity here, which is again a flaw of bag of n-grams. Also, if there's some word which is out of vocabulary, it doesn't really capture that because it's taking those numbers which it has been trained on, like student learn NLP. If it got something else, let's say if it gets high, it won't be able to capture that or to understand that. So that's why you know it don't understand out of vocabulary things. That's a flaw in bag of words. Okay, so let's implement bag of n-gram. It is somewhat similar to bag of words. It's a, you can say that extension of bag of words. So the implementation is also going to be similar with bag of words. Okay, so here first let's import libraries. Import libraries, which would include from scikit, scikit, sklearn, learn.feature extraction.txt import, not TF-IDF vectorizer, but we would be importing count vectorizer. Then we need to create an instance. Now before creating instance, we also need to read the file, okay, or open it. Now we have already done this step here, which we don't need to redo it again. So I think we don't need that, but just for the simplicity's sake we could also do here. That won't be any problem at all. Okay, so here we are reading the file, and now let's create the instance of vectorizer. Here we need to for n-grams we need to specify the range uh, for n-grams. It's already suggesting this would be for bigram. Now if we were to create unigram, this would be unigram. Okay, this would be unigram, this would be bigram, and if we increase the range then it would be trigram, and so on so forth. Okay, so for now just let's start with unigram, and then next thing is just fit the vectorizer. Where bag of words or bag of n-gram matrix is equals to clean data. Yeah, that's it. And the next thing is we need to print the features, which would be vectorizer.getFeatures names out, which would print the features name, and then let's print the bag of n-grams vector. Okay, so it's as simple as that. Now let's run this and let's see. Yeah, here you can see that it has done a wonderful job here. And yeah, so yeah, that's how it works. Now it is somewhat similar to, you can see that it's similar or it's identical to bag of words, because the range is 1 1, same as bag of words. But if we change it to 2, then you would see the change here now. Okay, now here you can see that it starts changing, like you would see that uh, it is now including 2 words at a time here also, and in so many other cases. And if we increase this, then you could see it has changed a lot. Alright, and you could go up and up. So let's just jump to 10, and this is what we got. So that's how it works. Okay, so hope you got the idea about how does we could implement bag of n-grams. Now, next we have term frequency inverse document frequency, which is again a method for representation of different documents into uh, numerical representation or vector representation. Tokenization, removing stop words, and normalization of after all these pre-processings, we got this data as before. Now here we extract unique words from all documents. Now, as I said before, for unique words we use the word vocabulary. So we will use these vocabulary: student, learn, NLP, and text echo. These are the four unique words. We would use these words to represent the documents in numerical format or in vector format. So first we will represent this using term frequency, which measures how often a word appear in a document relative to the total number of words in that document. For example, here we have tech uh, student. Okay, how many times does it appear in this document, which is what we call as the term frequency. So you can understand by the term frequency itself that it represents the number of the frequency of a number in a particular document. So we could mathematically represent as number of times word appear in document D out of total words in document. For example, if we talk about document 1, here student represent the here the frequency or term frequency of students 1/3, because students appears one time out of these total 3 words. Same with learn, same with NLP. Text echo doesn't appear, so it would be 0, and it goes same with the other words here. Okay, so that's how we could represent text a in numerical format or vector using term frequency. Then we have inverse document frequency or IDF calculation. So inverse document frequency measures how important a word is across all documents. So we mathematically we could represent this using this formula. It says IDF of any word is equals to log of n uh, divided by DF of words, where n is the total number of documents and DF document frequency is the number of total of the documents containing word W. Okay, so here you could see that the 4 words which we had, and the document frequency for student in the document is 3, because it appears here 1, 2, 3. So document frequency is 3, and the formula would be log 3/3, which is 0. And for learn we have 3/2 log 3/2, which is 0.16178, which rounds to 0.18. Then we have NLP, which appears 2 times, so it would be 3/2, which again rounds off to 0.18, and text echo same as that. So since student appear in all documents, its IDF or inverse document frequency is 0, meaning it's not important in distinguish between documents. Okay, so that's how we could use inverse document frequency to represent the importance of words in any document. To compute the TF-IDF, no, to represent TF-IDF, term frequency inverse document frequency, we could calculate that using term frequency minus inverse document frequency, which could be equal to TF multiplied by IDF. Here, by applying this formula, we would get D1. For student it would be 0 because it's not that important, and for learn it would be 0.6 after multiplying this with 1.3 1/3, I guess. Yeah, 1/3. So you get the idea that how we can calculate this. And same goes with other words like learn, text echo, and all. So that's how we could represent text using TF-IDF, and yeah, so that's how it works. Now the interpretation of this would be that student has TF-IDF score 0 in all document because it appears in every document, meaning it carries no distinguished information. And the word learn, NLP, text echo had non-zero values, meaning they provide unique value or representation to the document or the information document. And if a word is unique to a single document, its TF-IDF value would be higher. That's how we could interpret. If we compare the bag of words or the with bag of words with TF-IDF, bag of words doesn't really capture the order of words. Same goes for TF-IDF. It considers term frequency. Bag of words also consider, and both of them consider term frequency. Consider documents important. Bag of words doesn't really consider that, while TF-IDF consider that. And remove common words, it doesn't remove, while TF-IDF remove common words. And good for word importance ranking. It is not good for that because it doesn't really capture the importance of any words, while TF-IDF captures that. So TF-IDF is better for search engine and keyword extraction because it gives importance to single words. Therefore, it's better suitable for text extraction and or keyword extraction or search engines. And it reduces the weight of common words while highlighting unique ones. So that's a simple introduction to TF-IDF. We will also implement TF-IDF.
So here I would implement that as well. So first of all, let's import some important libraries, which would include from scikit-learn. Yeah, it's already suggesting us, that's great. And then let's open the file which we have already opened, but I'm just opening it once more time here. And then the next thing is we need to create an object of TF-IDF vector, which we could create as vectorizer, fit that data using this vectorizer. Okay, so for that we could use where TF-IDF matrix, which is equals transform clean data. Exactly, that's what we want. Then let's print all these print data features. So that's it, and print the matrix as well. Okay, so let's save it. Yeah, let's learn it. Let's see how it goes. So here you can see the output, that this is the whole data we have, and this is the output we got. Now again, if I just remove some text from here, you could see it more clearly if I run it again. So now here you can see that all these words are being clearly represented using TF-IDF. Okay, so that's all. I think we covered all the topics here. We covered all the implementation of different techniques of text representation which we learned in this lecture. I think that's more than enough. I hope you got the idea how we can represent text using classical approaches. See you in the next one. Till then, keep learning and keep improving yourself. Thank you.